This is a question on force on current carrying conductors, and over here we have two parallel wires carrying current in opposite directions. We can solve this question in three ways. I will introduce a third way that wasn't mentioned in class. So the first way is the easiest. You memorize that whenever there are parallel wires carrying current in different directions, there will be a repulsion force, and that's why the answer is D. The second way is something I've gone through in class by looking at the field lines. And over here you can see that there are two wires carrying opposite currents or currents in opposite directions, and basically what happens is in the space between the two wires, the field lines from both the wires will be pointing in the same direction. So this leads to a stronger field in the space between the wire, and we know that the direction of a force is always from a stronger field region out to a weaker field region, and hence we see a repulsion. Now, the third way will be as such. So we can use Fleming's left-hand rule actually to get the same conclusion of the repulsion force. So this is the third method. Over here I have recreated the two wires, the left wire with current going into and the right wire Y with current coming out. So we will focus on the right wire Y. So the wire Y experiences a magnetic field from the wire X, the current X. So if you look at current X, this is the direction of magnetic field around the wire. We can get this easily using right-hand grid rule. Just point your thumb along the direction of the current Ix into the screen or into the paper. You get a clockwise magnetic field directions. So over at the second wire, which is wire Y, we can see that the magnetic field is actually pointing downwards. And now we have two directions. The magnetic field that the wire Y experiences is downwards to the bottom of the paper or the screen. The current in wire Y is coming out of the paper or the screen, and therefore by using our Fleming's left-hand rule, you can conclude that the force on this wire is towards the right side of the screen or the page, and this clearly shows a repulsion force. We can repeat the analysis on the other wire X. So over here on wire X, it experiences a magnetic field caused by wire Y, and the blue color circular line shows you the magnetic field caused by a current in wire Y on the right. And we can see that the direction of magnetic field that the first wire on the left experiences is downwards towards the bottom of the screen on the page, and the current in the wire X is going into the screen or into your paper, and therefore by using Fleming's left-hand rule, the force on wire X is towards the left. Again, this shows the outward force between the two parallel wires, which is a repulsion force.